For Honors Math 2, in our first section, or in Unit 0, Section 1, we looked at exponents, and we had some basic exponent rules that we had to look at. The first one is, let's just say what an exponent is. If I have a to the b, or a base of a with an exponent of b, I'm saying that I have b amount of a. So if I said, for example, 2 to the 4th, that would be 2 times 2 times 2 times 2. So instead of writing all of them out, I can just condense it down and put the exponent there. Now, we could simplify that to make it 16, but we start to make that common jump from writing it in exponential form to get it to be the actual number. So we're not worried about so much of simplifying it that way, but actually using properties that start to show up when we have exponents. One is a to b times a to c. Now when I do these, notice how they both have the same base. So we could take and say, well, I have b amount of a, and I have c amount of a. And if I took them and spread them all out and then counted them all up, it would be the same thing as adding b plus c. So if I said a to b times a to c, it's as if saying just adding the exponents. So for example, if we did 4 to the 6th times 4 to the 3rd, we would be saying we have 9 fours. So it would be 4 to the 9th. Now that's a multiplication. It'd be a very large number if we went through and calculated it. We could also, a common one we see, is a to b to c. So that's going to be an exponent to an exponent. And in this case, we're saying we have this term, a to the b power, but this time we have c of those. And it's like sets of them. So we have each group. Each group is the same amount. Each group has b units in them. But we can see quickly how many we have. So this time, let's say we did 4 to the 6th to the 3rd. So that's saying I have 3 sets of 4 to the 6th. In each set, there's 6 4s. There's 3 of them. So we do 6 times 3 and say 4 to the 18th. Now notice, these are very different answers. So we got to make sure we keep them separate. So when you have separate bases that are the same, we add the exponents. When it's an exponent to an exponent, you're going to multiply. So we take these rules, and now let's look at some examples from it. So let's start with something like 6a squared times 5a to the 4th. Now, 6 and 5 do not have exponents. They are just coefficients to those values. So these we can actually just multiply together and make 30. But when we look at a to the 2nd, a to the 4th, they're really multiplied together. So it's almost like we've kind of added them all to the end. And how many a's do we have? We have 6 of them, so that's 30a to the 6th. If we then said, well, 4a squared b times negative 2a to the 3rd b to the 5th. For this one, we have 2 times, or negative 2 times 4, which is negative 8. A to the 2nd, a to the 3rd, that is 5 a's. b and b to the 5th, there's no exponent on b, so that just means it's a 1. So that means we have 1 and 5, so b to the 6th. So we can also add to that an idea. Anytime you have something without an exponent, it means it just has one of them. We don't have to write the 1. Kind of like the 4, the negative 2, and the 5, and the 6 we've already looked at. No value there, assume we have exponent. Because we just have one of them, it's the one that's actually written. Now it would probably be good to mention here that if you have anything to the 0 power, then in that case, it turns out to just be an answer of 1. Now, let's go on a little bit more. Let's do 2y to the 3rd. I haven't really looked at that. If it was just by itself 2 to the 3rd or y to the 3rd, we would just kind of have it written already as it already is. But in this case, we almost want to think that we're distributing out using the idea of just like distributive property, and we get 2 to the 3rd and y to the 3rd. Now, 2 to the 3rd is 2 times 2 times 2, which is 8, and we get 8y to the 3rd. Another way we could see this is we said we had 3 2y's. If I have 3 of them and wrote them all out, 2 times 2 times 2 is 8. 1, 2, 3 y's is y to the 3rd. Now let's add a little more along that idea and go x squared y to the third. So now it's like saying I have 3 sets of these. So let's write the long way out. That means I have x squared y to the third, x squared y to the third, x squared y to the third. And we go back in and count. I have 2, 4, 6 x's. I have 3, 6, 9 y's. And I get to the answer of x to the 6th, y to the 9th. Now going back and taking that idea of distributive property, I could have taken this 3, 2 times 3 is 6, 3 times 3 is 9, and I'd get to the same result, saving me from having to write it out the whole long time. Okay, let's go and look at something like 5x squared y squared 2x to the 4th y squared. So let's break everything apart and see what we have, because I got this squared here. So I actually have 5x squared y, 5x squared y, 2 of those, and then a 2x to the 4th y squared. And I'm going to take this and I'm going to now resort things. I'm going to put all of my coefficients or my numbers out in front. So I got a 5, and a 2. I have an x squared, an x to the 4th, a y squared. So now they're all kind of sorted. I put them together. 5 times 5 is 25, times 2 is 50. I have 2, and 4 plus another 4 is 8. And then 1, 2, and then another 2 is 4. So this comes out to be 50 x to the 8th, y to the 4th. One thing we have to be careful with here is make sure this 2 gets applied to all the terms. And what I did is I just wrote it twice and then went through, but sometimes, let's draw it over here, you could write this when it's 5x squared y squared. You could distribute out the 2, and you could make it 5 squared, x squared squared, and y squared. That would give us 25 x to the 4th y squared and get to the same result. It would still be there. Just be careful and make sure that 2 hits all the terms. If you write them out separate, that's good, but then when we start to see higher powers though, it's easier if we can distribute it out. So let's now go and look at, let's do a 4x squared x cubed squared 6x to the 3rd y to the 7th. So first thing I'm going to do is distribute out the 2 to the 4, the 2, and the 3. So I got 4 squared. I have 2x squareds, or 2 times 2 gives me x to the 4th. I have 2x cubes, so that's 3 times 2 is 6. That comes down with a 6x cubed y to the 7th. There is no exponent here, so I don't have to worry about that. Now, this becomes 16 here. Let's bring the other 6 out in front. I should make this a y, actually. Otherwise, it's redundant because we have x twice. It's meant for that to be a y. So I have x to the 4th, x to the 3rd is x to the 7th. Y to the 6th, y to the 7th is y to the 13th. Last thing we need is 16 times 6. Which is 96 x to the 7th, y to the 13th. Last one for us here. Let's zoom in a little bit and get rid of that other stuff. So now I'm going to take and do 2xy to the 4th minus 4x to the 4th squared. We don't want this stuff. Now, first thing I'm going to do is distribute this 2 into the terms inside the parentheses. But we have to be careful because that negative 4 is its own term. So it becomes negative 4 squared and then x to the 4th squared. And why that's important is negative 4 squared is positive 16. If you just look at the 4, you'd leave it as negative and you'd make it negative 16, but that's not following the proper rules. So that becomes 16. I have 2 sets of 4, so that's 4 times 2 is 8. bring down a 2 times x, y to the 4th. So now from here, 2 and 16 is 32. X and x to the 8th is x to the 9th, and then y to the 4th is our answer.